let's do some more examples on this parametric format. Here it asks what curve is represented by this parametric equation. So the starting point of t is given as 0 and the end point of t is given as 2 times pi. So in order to answer this question, or I mean in order to get an idea about the shape of this curve, one way is to extract out a relationship in between x and y, because then we can plot that relationship in a xy plane. So in this case also, since you have some simple trigonometric terms, we can easily get a relationship between x and y. That is, by if we square x, you will get cos squared t, and if you square y, you will get sin squared t, and when you add these two things, then it will be equal to cos squared t plus sin squared t, and that is equal to 1, and this is a standard trigonometric relationship, right? So ultimately what we have is this relationship. Now see here, we started with a parametric format. That means we have expressed x as a function of t and y as a function of t, and then we got rid of this third variable and wrote down a relationship between x and y directly. And also we know that this represents a equation of a circle. Now although this equation represents an equation of a circle, now the thing is this, whether it forms a complete circle or not is decided by the values of t. I mean the starting value and the end value of t, right? So to get a better understanding, let's try to plot the graph. Well, now this website is also a good way to plot all our simple curves. It's a free website where you can easily plot almost all the curves that we come across during our calculus class. So even for this particular case, now here we can even represent, we can even plot parametric curves through that website. So to plot the parametric curves, this is the way you have to do it. You just have to have a bracket like this, a parenthesis, and then you have to mention the x coordinate which is cos t and the y coordinate is sin t as two terms within that parenthesis. So x is represented as cos t and y is represented as sin t. Now by default they set a starting point and an end point for the parameter t. But let's say if we start from 0 and end from 0, that means what if we consider just a one single point? In other words, how about the value of x and y when t is equal to 0? What will happen to x and y when t is equal to 0? So then x will be equal to cos 0, which is equal to 1, and sin will be equal to y will be equal to sin 0, and that is equal to 0, right? So that means we have the 1 0 position, which is this coordinate. So even in our graph we can see that point. If we zoom in now, if we zoom in at this 1 0 position, we can see that there is a small dot over this coordinate. So, and if we start increasing this point, let's say 0.5, see, it will draw everything starting from 0 and up to 0.5, right? And in our particular case, they have given the starting point and the end point as 0 to 2 pi. So let's say if we draw the graph from 0 to pi by 2, then you can see that it will complete a 1/4 of a circle. And how about pi? It will complete the half circle. And then pi over 2 times 3, that is 3 pi over 2, so it completes the 3/4. And if it is 2 pi, then you can see that it will complete the whole circle. So only because you have this interval, you will get a full complete circle. Otherwise, even though this relationship is for a circle, if we have a different domain, then we will get a, let's say if we have a domain as this one, then we will only get the half circle part. Even though we have this relationship, the exact figure will also depend on the starting point and the end point of the parameter t.